Today's recording is for Algebra 1, Chapter 2, Lesson 3, and the quote comes from Horseradish, Bitter Truths You Can't Avoid by Lemony Snicket, page 92. If an optimist has his left arm chewed off by an alligator, he might say in a pleasant and hopeful voice, "Well, this isn't too bad. I don't have my left arm anymore, but at least nobody will ever ask me whether I am right-handed or left-handed." But most of us would say something more along the lines of, "Ah, my arm, my arm." All right. Math. Variables on both sides. No sweat. Continue to use addition and subtraction properties of equality to move not only numbers, but variables as well from one side of the equal sign to the other. So let's go ahead and do this first problem together. All right. So we have 2 times the quantity c minus 6 is equal to 9c plus 2. So before I do anything, I'm going to add the opposite, and then I'm going to distribute. So 2 times c is 2c plus 2 times negative 6 is negative 12 equals 9c plus 2. So now, sorry, Miss Michelle walked in. All right, so now that we've distributed, we need to combine like terms. Now again, I like to move things over so that I have a positive coefficient on a variable, but you can move either one. You can move the 2c or the 9c, but I'm going to choose to move the 2c. So the opposite of 2c is negative 2c, so I'm going to minus 2c on both sides, which is going to leave me negative 12 is equal to 9 minus 2 is 7c plus 2. Now I still need to take care of lower priority stuff as opposed to higher priority stuff first. So I need a minus 2 on both sides, minus 2, and that's going to give me negative 14 is equal to 7c, divide by 7, c equals negative 2. And again, you can plug it back in for c, and it will work for you, okay? And that's just to double check. All right, next problem is going to be negative 6d equals d plus 4. So I'm going to go ahead and move over some stuff. Now, normally, I would move over the negative 6d and do the opposite because I want to come up with a positive thing. The only thing is if I add 6d on the left side, I'm going to get 0. And that's okay. You can do that because you're just going to move the 4 over because you still need to get the d by itself. The whole point is to get d by itself, all right? Remember your mission from yesterday? Well, it's to get the d by itself. I can't remember if that was your video or not. Anyway, we're trying to get the d by itself. So I am actually going to minus d over here and minus d over here. And remember, there is an invisible 1 in front of those d's. Okay? So now I have negative 6d plus negative 1d, because I went ahead and I added the opposite. So negative 6d plus negative 1d is negative 7d, and that equals 4. So now I'm going to divide by negative 7, divide by negative 7. The 7s are going to cancel out, the negative 7s are going to cancel out, and d is going to give me negative 4/7. Okay? All right, next problem. We have m minus 5 is equal to 3m. So again, if I minus 3m on the right and on the left, I'm going to end up with 0 on the right. So I just personally kind of want to avoid that. You don't have to avoid that. And just remember that there's an invisible 1 in front of that m. So I'm going to minus 1m. Minus 1m. Negative 5 is equal to 3m minus 1m is 2m. Divide by 2, divide by 2. M is equal to negative 5 over 2. All right, last one of these problems, and then I've got 2 word problems for you guys. All right, so I need to move some stuff over, or I can still add the opposite. There you go. So I'm going to minus 5k, minus 5k. Again, you could have minused 7k on both sides, and that would have been legit. You just would have ended up with a negative coefficient. All right, so 7k minus 5k is 2k. Plus negative 4 equals 16. What's the opposite of negative 4? Well, the opposite of negative 4 is positive 4, so I'm going to add 4 on both sides. And I'm going to get 2k is equal to 20. Divide by 2, divide by 2, k equals 10. There we go. All right, we are ready for the next word problem. All right, so the word problem is an application problem, as most word problems are. You can either buy skates from a friend for $40 or rent. Regardless, you have to rent safety equipment. How many hours of rental are the cost will make the cost of the situation same? That sentence is a little wonky. Okay, but as you can tell over here, they give us some information. Safety equipment rental is $1.50 per hour, whereas skate and safety equipment is $3.50 per hour. So let's go ahead and set up this equation. So how much is it if you buy the skates from your friend and only have to rent the safety equipment? Well, it's $40 plus $1.50 times every hour that you need the rental equipment, because you own the skates, so that's a one-time fee. But since you have to rent the safety equipment by the hour, the number of hours that you rent it will make a difference on how much you pay. So because we want to figure out when the situations are the same, they're equal to each other. So when is buying equal to renting? Well, renting is $3.50 per hour. So basically, if you're ever going to want to do more than the hours to this question, if you ever want to skate more hours than we figure out for what H is, it's going to be cheaper to buy. All right, but if you don't, it's actually going to be cheaper to rent. So if you only plan on skating like 5 hours and we figure out that it needs to be 40 hours for to make these two situations equal, then buying would be more expensive than renting. Okay, so let's go ahead and figure out this question by combining like terms first and getting things on the same side of the equal sign. So we have 40 plus 1.5h is equal to 3.5h. So I'm going to subtract 150h on both sides, 150h. And I'm going to get 40 by itself is equal to, well, 350 minus 150 is, well, that's 0, and that's 2. So 2h, divide by 2, divide by 2, h equals 20 hours. So if you are going to skate for 20 hours, it doesn't matter whether you buy or rent, because it's going to cost you the same overall, all right? If you skate for 20 hours and you bought the skates, those 20 hours will cost you the same for renting the equipment for safety as it would for renting the skates and the safety equipment. But if you wanted to skate for more than 20 hours, buying the skates would be cheaper than renting. But if you're going to skate for less than 20 hours, renting would be cheaper than buying. All right, last problem. All right, we have a hairdresser, and she is considering, or he is considering, ordering shampoo. Shampoo Company A charges $4 per bottle and a $10 handling fee. Shampoo Company B charges $3 per bottle and a $25 handling fee per order. How many bottles must the hairdresser need to order to justify going through Company B? Because Company B is going to be more expensive if you buy bottles under a certain amount because of that handling fee, whereas Company A will be cheaper up to a certain point because of their handling fee, even though they charge $1 more for their bottles. Okay, so we basically just need to figure out at what point are they equal, because once we go over that point, the point where they're not equal anymore, Company B is going to be cheaper than Company A. But currently, Company A is cheaper. But we need to figure out, again, the happy point where they're the same amount. So, Company A is and then this is a B, by the way. That's the letter B. $4 times the number of bottles purchased plus $10 handling fee, and we need to figure out when that is the same or equal to Company B, which is $3 per bottle. That's a B, by the way. That's a B, plus the $25 handling fee. So let's go ahead and solve this problem. So let's see here. So we've got 4 times B, which is 4B plus 10 is equal to 3B plus 25. So again, I need to get all of the B's on one side so that I'm only dealing with bottles. So I'm going to minus 3B on both sides, minus 3B. That leaves me 1B plus 10 is equal to 25. I'm trying to get everything away from the b, so I'm going to minus 10, 1b, or just b, because anything times 1 is itself, so b times 1 is b. 25 minus 10 is 15. So you would have to buy 15 bottles from both companies for the price to be the same in total. Now, if I bought more than 15, I need to go with company B. If I buy less than 15, company A is cheaper. All right, there we go. All right, I believe that's it. Oh, when bottle prices, oh, never mind, you can ignore that. Oh, no, there is more. Never mind, I'll keep going. Okay, so we need to talk about some special cases. So special cases are identities and no solutions. And all the problems we've done up until this point, every problem we've done has had one solution. The variables equaled one number, all right? But you can get some equations where there's actually no solution. There's no possible answer for the variable. There's no possible number that if you replaced it with the variable, you're going to get a true statement, okay? It doesn't happen. It's mathematically possible. And then you're also going to have an equation where no matter what number you put in for the variable, it's going to give you a true statement. It means that the variable can be anything, okay? And some equations just have one solution, which is what we've been doing for the last few slides. But let's go ahead and look at two examples where there isn't one solution. All right, so determine whether each equation is an identity or whether there's no solution. An identity means that no matter what number you replace the letter with, it's going to work. No solution means there's no number in the existence of human beings that would ever work for the variable to give you a true statement. Okay, now the best way to figure these out is to simplify. So I'm going to go ahead and simplify. And so if we have an identity, both sides of the equal sign are going to be exactly the same. If we have a no solution situation, both sides are going to look similar but be slightly off. Okay, so let's go ahead and do the first one. I'm going to distribute. So 2 times 5 minus 2 times 4 times a. So it's 10 minus 8a is equal to 10 minus 8a. Oh, and I can add the opposite. There we go, add the opposite. All right, so, whoa, actually, even if I don't add the opposite, it's exactly the same. This side is exactly the same as this side. 10 minus 8a, 10 minus 8a, which means no matter what I plug in for a, that's a really light color, no matter what I plug in for a, it's going to be true. You know, I could plug in 2 for a, and it's going to give me a true statement. I can plug in 40 for a, and it's going to give me a true statement. I can plug in negative a million, and it's going to give me a true statement. So when one side is exactly the same, when one side is exactly the same as the other side, this is what we call an identity. Okay? Again, both sides exactly the same. Well, let's go look at another one. Well, these sides are kind of close. We've got a 5n and a 5n, but this plus 9 and this minus 1 really throw us off. You have to look for these really closely because you could have something like 5n plus 9 is equal to 5n minus 9. If you're not paying attention, you're going to think this is an identity, right? But they're not. Because they're very close, but only slightly different, that means that it is no solution, okay? And these can be a little tricky to find because you might also think that it has a solution or one solution when it really doesn't. There is no solution. Basically, one way you can look at it is if you can cancel out the variable, there's a good chance it's no solution. Now, I'm not saying that it happens every time, but if it happens, you might be looking at a no solution situation. Okay, so sorry this was long. Probably should have skipped quote today, but happy talk like a pirate day. Bye, guys.